everyone, welcome back to SAT Math Question of the Day. These questions come from the educator side of the SAT, so spoiler alert, you may see this question on a Blue Book test. Okay,
Yeah.
So here we go. I just have to set up my annotation. Okay, for the linear function f, the table shows three values of x and their corresponding values of f of x. Function f is defined by f of x is ax plus b, where a and b are constants. What is the value of a minus b? Okay. So one would think immediately to look for a pattern. Is there a cute way to get a minus b almost immediately, as opposed to writing the equation for writing the actual, find out what a and b are, and then subtracting? Question is whether it's going to take more time trying to be super clever as opposed to just doing it the normal way. So let's just try doing it the normal way. The normal way, you would need a slope and the y-intercept. You could see the slope is m is 64. Why is the slope 64? Because if x goes up by 1, then f of x goes up by 64. And we're told it's a linear function, so m is 64. So we could
that means a is 64.
Yeah, a is 64. The slope, by the way, linear function is mx plus b. M is the slope.
No, the slope is not mx plus b.
No, the slope is not. The equation for a linear function is y plus mx plus b, where m is the slope and b is the y-intercept.
And when y is given by ax plus b,
right,
the slope is a.
That's exactly right. The slope is a. So we know this. Now, it's easy enough to find b. Let's use this one. When x is 2, f of x is 0. So 64 times 2 plus b. So b is negative 128. Now you've got to be very careful, because on the SAT they want to see if you're making sure how to add or how to deal with negative numbers, not to deal with integer arithmetic with negative numbers. If a is 64 and b is negative 128, then we're talking about 64 times 3. So, 64 times 3. So, 64 times 3. 192.
Just add 64 to 128, and that gives the answer.
You could also do that.
Yeah.
If you can either do that in your head, on paper, or in a calculator. That's why you should bring a calculator with you, because otherwise you have to spend your time opening Desmos and then opening up another click on the digital SAT. So that's what it looks like it is. Now, the question is, was there a super clever way to see that? Could you have set x to be something? Is there a pattern to this question where you could figure out a minus b directly? Or do you think they're teasing us?
Well, unfortunately, they do not include in the table of the entry for x equals minus 1.
Well, we could do that.
If they told you that.
Well, we could figure that out.
Yeah.
0 is... Wait. Well, what's the function? We'll cheat. It's 64x minus 128. 0 is minus 128. So negative 1.
If you put in x equals minus 1.
Yeah, negative 192.
And then whatever you get, you take the negative of it. That gives the answer.
Right. So f of negative 1 is negative 192.
Yeah.
So.
Okay.
And that's
so here's another approach. Let me
Wait, let's finish this one off. F of negative 1 is that.
Yeah.
So that would mean a times negative 1 plus b. So that would be negative a plus b. So f of negative 1 is negative a plus b. But we want a minus b. a minus b is equal to -1 of negative a plus b. So
Yeah.
Seth's right. Seth's right. If we can calculate using patterns negative a plus b, so then
Okay,
the
now
answer,
let me show you a pattern method.
go ahead.
I think I'd like you to kind of make some space for me.
Yes. Request granted. So let's see what we can do for you, Seth. How about, can we give you this box? Is that going to work for you?
No.
Oh,
Get the whole left hand, lower that box and make it into an actual rectangular box.
that assumes we
Oh,
know what a rectangle is.
okay.
Okay, go
Now I'll
ahead.
do it.
It's all
Okay.
yours.
Here
It's
we
all
go.
yours.
Pattern.
Pattern. I can't love. We
What's the
love
pattern?
patterns. We love.
What's the
We have to know
pattern?
the patterns because it helps us for future tests.
Here's the table. This is the X column, and this is the f of X column. When X is 2, f of X is 0.
Got it.
How come it's okay? When X is 1, f of X goes down by 64.
Right.
So when X equals 0, the 64 goes down by another 64 to get 128.
Absolutely.
And then when X goes to -1, it goes even further.
That's right.
To negative 128 plus 64, which you could
Minus
figure out
negative
as
192. Negative 192.
8 and 4 is 2, 6, 8, 9, 192. Negative 192.
Negative 192.
And therefore, a minus a plus b equals negative 192.
Yeah, we just did that.
And therefore, a minus b is positive 192.
We just did that, though. Wait, we just did that.
Well, what I did was I was not explicitly formulate the slope. What I did was use the pattern that every linear function has. That when you step equal steps of x, the y value also steps by equal steps.
Yeah, but what about this? Why did you bring this in? Why did you write that? What prompted you to write that?
Because if you knew f of -1, then you could immediately tell what a minus b is. How? You take your f of -1, and you mentioned this already, but I'll say it again. You take your f of -1 and take the negative of that.
Right. Yeah, we already did this method, son.
I know we already did it, but what my approach is that instead of fussing with saying, hey, the slope is whatever it is, figure out what the slope is, what you do is use a pattern.
Seth, I did that.
Step your way.
Seth, I did that here. What do you think I did? How do you think I got 0, negative 128 so fast? I did that.
Did you?
Yeah, I did that. I did that right here. I said, make it go down by 64. Make it go down by another 164. I did that already.
Okay.
I did that already.
All right. Well, you said what you did was figure out that the slope is 60. Yeah. Okay. All right.
Well, the thing is, we already knew the slope was 64, but the thing is, so the question is it faster? Well, it depends on the person. If someone sees the pattern here, that f of -1, and so the answer is f of the bottom line, the formula for this particular problem is a minus b is negative f of -1. Those who see this may get the answer faster. The question is, does it take more time to figure this out than it is just to do the problem traditionally. I don't know. I guess it depends on the person. The person with the super high IQ who's really good at seeing patterns would see that. What would you have done? I jumped in and did it. Which way would you have done it? Would you have done it the super clever way or the traditional way?
I think if I face this bear, I would do it the traditional way.
Yeah. Yeah.
Yeah.
Oh, yeah. Okay, so I hope we explained it well. That it's a linear function, and you want to get the slope in the y and the b, and you calculate the two coefficients, and then you go from there. By the way, this is a coefficient algebra problem. SAT. You guaranteed you will get at least 3 to 4 of these problems on your SAT. If you go back to the Blue Book test, you go back to what they ask. A coefficient problems on functions is one of the most popular of the more sophisticated problems they ask. So be ready for these questions. And I think we talked about why. Because in a situation like this, either they give you the equation and you have to do something with it, or they give you some characteristics of the function and you have to figure out the equation. It's the backwards question. And that's why it's so incredibly popular, and that's why these questions are a little harder than the question where they just give you the function, you have to do something with it. Okay, so should we see? Questions. I know, and questions. We asked calculator question. Well, yeah, sure, I used it 3 times 64, but you didn't really have to. Or add 92, add 64 to 128. Calculator may help. Start with a guess. No, starting with a guess doesn't. No, that doesn't work. Pattern. We already showed the pattern. Yes, we showed a pattern to this question. If you have the high IQ to figure that out ahead of time. Different from a school test.
That high.
Yeah, well, different, certainly higher than ours. Different from a school test. No, I mean, unless the teacher is looking at the educator site and wants to train you for parameter questions for the SAT, which they really should. Teachers, if you're watching this, take note of this. Parameter questions on the SAT are incredibly popular. They tend to be the harder of the questions on the SAT. Try to train your kids for this. Right now, you don't normally see a question like this on a math test. Maybe that'll change. Drop my stylus. And the main idea. Okay, the most important question we have. Why did the test committee put this on the test? What were they trying to see, if you know what to do? Figure out how to, given a table that represents a function, how to write it in algebraic form. And I would,
I'd say 2 things.
Yeah.
And say 2 things combined into one is to relate the table form of a linear function to the slope-intercept form.
Well, the algebraic, to an algebraic form.
Well, in this problem, in particular, the algebraic form is the slope-intercept form.
That's right, but in general, it's the algebraic form.
And so, the connection, understanding the slope-intercept form, is worth having in your preparation, but as a self-standing skill.
Yeah, of course. Yeah. Well, I've said in other. Wait, you said 2 things. What were the 2 things? You said they were combined.
One thing is tabular forms of functions,
right?
And the other is functions in slope-intercept form.
Right. Okay. Yeah.
And what I said was, it's a good idea to be able to know together the connection between for functions that have a slope-intercept form, what's the properties of the table, and given a table, how to deduce the slope-intercept form from data in the table.
And in general, I've said before that, and it's very, very important to think or be ready to think in three modalities with functions: the tabular form of a function, the algebraic form of the function, and the graphical form of the function. And you should be versed in all three modalities. I sort of call them languages. You want to be able to switch from one to the other. And in certain problems, one modality is more efficient to use than another modality. And here they're asking you to transfer them. I wonder whether in Desmos you could type a few points in to get an equation. I'm wondering. I'll have to look that up and see whether if you use a calculator, whether you could put a few points in Desmos and it'll graph it or not. But I'm not sure. Anyway, okay.
You could imagine or scribble on a piece of paper. You could graph the function.
Yes.
You plot the point 2, 0.
Yeah, let's actually check that out. Actually, that's yeah. So let's talk about that. Yeah. You can make rough graph paper. I don't think they give you graph paper, but you can certainly go like this, and you would make them all 64s. How about that? Right, and then negative 64, right? So you do 2, 0. Wait, 2, 0. No, that's not 2, 0. What am I doing? That's 1, 2. That's so stupid. That's so stupid. Negative 1, negative 2. 2, 0. So 2, 0 is here. 1, negative 64. 3, 64. Ah, look at that. So immediately you know the slope is positive. That's important. And then the b is the y-intercept. You could see immediately that this is negative 128. And a is the slope. So it's 64 minus 128. Wow, look at that. Just writing a rough graph. Boom. That may be the fastest way to do it. Doing a rough graph doesn't hurt. That was really efficient. That was fast, wasn't it? Except you're either
I like that. Yeah. So it's another mode.
That's the best way to do the problem, actually.
Yeah, that's nice. Yeah.
And this is also something, follow how we're thinking. When we do is we look at a problem, we look at it from all angles. So I know it's really, really hard when you're studying for the test to be able to have the patience and the time to look at a problem and think about other ways to do it. Most people in high school aren't going to do that. But think about how we do it and how useful it really is and how we just learned it. Yeah, graphing it was actually the best way to do it. Toy with each problem as you're doing it. Spend some time on each problem. Or just sort of listen to us do it. Okay, so I guess let's see how they did it. Okay. Yeah, graphing. Whoa, what a way to go. Okay, so we clear all drawings. We close this thing. And we do the big reveal. Okay, so their answer isn't very long. Oh, okay, yeah, we already talked about the main idea. Choice D is correct. The table, Seth's nodding his head in a negative way. That doesn't look good, unless he's reading it. The table gives f of x 0. Substitute the equation yields 2 is equal to... Oh my god, what is this? This is like a super clever way of doing it. Subtracting 2a from both sides of the equation yields b as negative 2a. The table gives us that substituting negative 2a for b. Substituting negative 2a for b, negative 64 for f of x, and 1 for x in the equation yields... Wait. What? What did they do? Do you understand this? What did they got A and B in a very weird... Doesn't it seem like they got A and B in a very weird way?
Yeah.
What? Why didn't they just do it the normal way?
They did all that 4 lines. They spent 3 and a half lines to figure out the value of A.
The slope.
Yes. That was really dumb.
Wait, do you just look at the table? If it goes from
Yeah, yeah.
1 to
They
2.
did. They spent. Yeah, they did was batter at it. They battered at it the first thing, the conventional approach, and somehow they flailed about, and they took 3.5 lines to figure out the slope. Whereas you could read the slope right from the table.
Yeah, right here. Yeah,
one step.
Goes up by 1, goes up by 64.
Yeah, yeah.
But what
They
is this thing
completely
about
missed
why,
that.
why do you need this B minus 2A thing? Why do you even do that? Oh, so that you have a formula for B. But you don't have to derive any formulas. You're not deriving formulas in this problem.
So then they did another messy thing to figure out what B equals.
Which is completely unnecessary.
So what they did was they flailed about to first calculate A and then calculate B, and then to get the question was, what is A minus B? They took their two answers for A and B and subtracted them.
Mm.
It makes me shake my head why, it's...
It makes me shake my head.
No. That's not the way to do math.
Wait, what type of expression is that? Makes me shave my head? What did you say?
It makes me shake my head.
Oh, shake your head.
Shake
my
head.
I thought it was like a... Okay, I thought it was a...
No. I don't have to shave my head.
right. I was wondering. That's some sort of, expression I never heard you say before. Or a common idiomatic phrase. But one thing we did forget to say about a main idea, what they're testing to see if you know how to do, is how to handle and how to not be schleppy with negative integers. Subtracting negative integers, you got to slow down. It's 64 minus a minus 128. If you go too fast, you're going to make a mistake with negative numbers. Anytime negative numbers in the house, you got to watch yourself. So that was another thing they probably were testing, because they could have given a problem where you had, let's say, 100 minus 30, where, obviously it's going to be 70, but they messed it up, and they gave you some double negatives there. Okay, so I'm Joel. I have a PhD in mechanical engineering. Seth, my brother, is outside. It looks great out there in Albany. It's a PhD in math. We try to meet every day to go over in one SAT math question. We try to offer different approaches. We analyze it ad infinitum just try to analyze it from all different lenses, angles, and approaches. We have different people. We come from different backgrounds educationally, although we are fraternal brothers for real. We're genetically related. We just try to offer different ways to view the problems. What you should do, we strongly suggest you take all the Blue Book practice tests. We've heard rumors that Blue Book 4 and Blue Book 6 are the closest to the actual SAT, so focus on those. See how you do on those. And if you have any particular topics that you want to strengthen, go to the Khan Academy site. They partner with the SAT. They basically tell you what's on the test. Do as many practice questions as you can there, particularly on the stuff you're weak on, but also practice on the stuff you're strong on so you can do it much faster. So I guess that's it. Please dislike our videos. We take all the comments. Please comment on our videos. We take them all very, very seriously. And I just want to see real quick. We're basically done. I just want to see really quickly on Desmos. Can you type in points on Desmos? Let's just see. So I just shared the screen. Annotate, kill all the annotation. Can you type points in? Can you just go like 0,3? Okay. And I don't know, 8,4. 8,4. Oh, 8,8. How about 1,2? Yeah. Look at that. Look at that. 0. I already have 0. 3. Well, we already have a line, right? 2 points make a line.
Yeah.
2 points make a line. If we give add any more points, then we got a problem. Look at that. And I guess you could therefore see the, yeah, look at that.
What if you can you click on a point and do something? You can't draw a line between 2 points.
Yeah, we would have to see whether you can, you can put labels on them. You can label 8, you can call it 0.8. That's sort of stupid and not useful for us. So, yeah, you could just draw some, so, although, frankly, it's faster.
Now, does it adjust the scale? What if you gave it 0.64?
Right, good point. Yeah, good point. Maybe, 0, well, it was actually 0. Yeah, it was 0.
Doesn't matter.
Ooh. Well, then you have to go like this. Hopefully you have a touch screen. Ooh.
There it is.
Oh, 0.64, right, all the way up there,
Yeah.
And I think there's a way. Oh, yeah, here it is. Yeah, you can go like that. Oh, but you can't see it as well.
Oh, there we go. You can scale it. Yeah.
Yeah, you can scale it like that. Yeah. Yeah. Actually, it would be faster if you're going to do the graphical approach, which really is the best way to do this problem. Just draw a little picture like we did. And don't be silly. Just draw a little thing that go like this and put the points in. What is it? 2, 2, 0. It'll put 2, 0 in here. And then 3.64, right? And then go like that. And then boom, you got it. 1 negative, right? Yeah. Okay, everyone, we're done. Okay, have a great day. Hope to see you tomorrow.
Okay, see you later.